We're now going to proceed with the last part of the surface time-dependent forcing extraction, and we're going to extract now the the time-dependent fresh and heat water fluxes. So once again, I'm going to go in the ROMs NC file directory, and in here, I'm going to open the main NC file, the main NC file underscore fork file, and again, in the configuration, I'm going to work with the N-Pacific grid, and I'm going to enable the time-dependent forcing by setting this to 1. And I'm going to scroll down to the time-dependent forcing. So this first part is relative to the wind stresses. We were doing, for example, from year 1997 to 1998, and this was the wind stress component. And as you see, you can choose whatever dataset you want. Now I've decided to just use for the purpose of this the NCEP reanalysis for this period. And so then I go down further down here, and this is the section now that it covers all the other variables. And so similar to what we did before, we basically assign a time, the time in this case datenum month that for which we want to extract the product, and this is going to be the dates using the datenum format of Matlab. It's in days, and the fork type is going to be monthly averages, and so here then again I have to define the option array that has the number of time records for each of the forcing variable, the length of a cycle in this case is 0 because this is just one realization, it's not a periodic forcing. And then the actual values of the various records in the forcing file. In this case, IDN val, which is the mid date of every month from 1997 to 1998. At this point, I create the name of the forcing file, similar to what we did before, and we create an empty forcing file. After having done that, then I have to extract the various forcing fields. So the first part is going to extract the time-dependent SH flux, SW rad, and SW flux from the NCEP reanalysis, and it's going to use this function here, RNC extract surface fluxes NCEP and so forth. For the sea surface temperature and sea surface salinity, for now I'm going to use the Levitus climatology. And in fact, this particular extracting function is going to extract the climatology for salinity and sea surface temperature. And because this is a time-dependent forcing and you don't have time-dependent salinity and SST in this file, this function will only return the monthly values. So for every month, say the January 1997, January 1998, it's just going to return the monthly climatology for January. So it's not really going to be time dependent. However, and that's typically true for the sea surface salinity, for which we don't have a lot of data. But for the sea surface temperature, you can actually use other products like the NOAA reconstructed sea surface temperature, which are time dependent. And so here now it's an extraction for the SST using this extract NOAA SST. And this will return the time-dependent SST field, and so we're just going to store it in this other fork array, and then we're going to use the interp2 grid to save it into the forcing file. The last field that we're going to extract is DQDSST, and the DQDSST is also only available as a monthly climatology, and so in this case, for every January, it's just it's going to replace the value with the monthly average, with the monthly climatology of January. So in other words, the January 1997 and the January 1998 of our forcing file is going to look the same. So with this in mind, then once we configure this, we can save this, and then we can go in Matlab. We can go in the directory ROMs NC files. We can fire up Matlab, and all we need to do again at this point is to just run this function here, the main NC fork, and you can see again it's extracting first the surface UNV stresses for 1997 and now for 1998, and this is the first part that we've seen also in the previous example, and now it's interpolating those, and once it's done with these UN wind stresses, it's going to start loading these variables, NL, WRS and stuff and so on. These are all like terms of the heat flux that are extracted from NSEP that are going to be used to actually compute the net surface heat flux. So these are all the various components from latent heat to and so forth. PRAT, I believe, is the precipitation rate or something. And so now it's extracting the 1997 data, now the 1998 data, and after this extraction, it should interpolate them. So we're just going to make sure that it works. Okay, so it seems like it's working. It's doing the various months. So now you see it's going to go up to 24 months since we have 2 years of forcing. And it's creating, now it's storing in this file in Pacific 1997, 1998. Now it's doing the sea surface temperatures and sea surface salinities. So we're basically in this part here of the file. And we just have to wait until this is done. In the meantime, we can close this. We can do ls minus LTRA, and we find that in fact we have two forcing files. One is the winds for this period, okay, 1997, 1998, and the other one is all the other forcing fields. In this case, the freshwater and the heat fluxes for that same period. We can actually look at one of these files. And you can see that this one has, the SH flux, the surface heat fluxes, the surface freshwater flux, and so forth. And you see that they're all defined. Okay, so let's see. This is almost it's doing the second year, 1998, month 8, month 9, 10, 11. 12, and now it's interpolating the salinity very well. Now the SST, and now it's doing DQ the SST, which is the last bit. But in other words, these files are now here and can be used to run the model. So to summarize, then, if we go back and we open this, we can. All we need to do here then is at the beginning is we configure the type of the grid. We decide whether we're going to do a seasonal cycle forcing or a time-dependent forcing. If we do the time-dependent forcing, we may want to customize some of the forcing functions. For example, we can select here whether we want to do monthly or daily forcing here. We can select what type of wind stress product we want here. We have a couple choices. And then we go in the second part where we do the extraction of the NSEP reanalysis, surface freshwater fluxes, and so forth. Now, please keep in mind here that, for example, here you have that you're extracting the surface, the monthly value. The fork type is monthly here. So really, a better way to do this is to actually change this and put, for example, fork type. I'm going to do that as we speak, and so that's for the thing. This one is for the climatology of sea surface temperature, so that stays that way, and all these others can stay the way. The no SST product, by the way, only comes at monthly resolution. So even if you were to extract this at daily, it would still provide you the monthly value, okay, because that's only the resolution at which the data is coming from. Now in the next demo, we're going to actually look at some of these extracting functions so that if you want to add your own data set, you can do it yourself. But here this is complete, and so with no errors, this demo is completed. Okay, thank you.